Welcome to JoJo Maths 10th Standard CBSE Mathematics Chapter 1 Real Numbers Theorem 1.1 Euclid's Division Lemma. Now we can see the statement of this lemma. Given positive integers a and b, then there exist unique integers q and r satisfying the condition a equal to b into q plus r, where the r should satisfy the condition r should be less than b and greater than or equal to 0. Now we can see in this statement we can see an equation. What is the equation? A equal to b into q plus r. Okay, so this equation deals with 4 integers a, b, q, r, and here we have to note that q and r, these both are unique integers. So what do you mean by unique? Unique means they are unreplaceable. That means only q and r can satisfy this equation and none other variables can replace this q and r in this equation. So only we are denoting it as unique integers. Okay, so also another one condition, that is this r, this variable r should satisfy the condition, that is r should be less than b and greater than or equal to 0. So to understand this equation clearly, that is the statement of this lemma clearly, we can solve this by just considering one simple example. By solving one simple example, we can easily understand this lemma. Okay, now consider one example. Consider any two positive integers. Any positive integers we can take. So now let's consider some integers 45 and 4. Okay, so here 45 some largest integer and 4 come one small one digit integer. Okay, so here now take this 45 as a. Let us denote this 4 as b. Okay, we are just considering some integers, positive integer, and this one is a and this one is b. Now substitute these two values in the given equation. What is the given equation? A equal to b into q plus r. Okay, so now consider now substitute the values of a and b in this equation 1. Okay, substituting a and b in equation 1. What is the value of a? 45. So 45 equal to, what is the value of b? 4. So 4 into q plus r. Okay, now see, now we have to find the value of q and r in this equation. In order to find the value of q and r, now see here, this q is in product with 4, isn't it? In this equation q is in product with the integer 4, that is q is some multiple of 4. So we can, so what? Here 4 is the, here q is some multiples of 4. So in order to find the value of q, we can divide this number 45 by 4. Okay, so 45 can be divided by 4. That means we can find the value of q easily. So how can we divide? 45 can be divided by 4. Okay, so one time, then we get the remainder 0. Again bring down 5. So one time 4, remainder 1. See here, here we all know 11 is the quotient and here 1 is the remainder, isn't it? So now substitute this value of quotient as q and take here 1 is the remainder, no, that is r. So now instead of q and r in this equation 2, we can substitute the values of q as 11 and r as 1 in this equation 2. Okay, so then equation 2 gives 45 equal to 4 into, instead of q we substitute 11, then plus r is equal to 1, so 1. Okay, see here, and so Now we have written this 45 as 4 into 11 plus 1. Also we have one condition in our equation, isn't it? This r should be less than b and greater than or equal to 0. Now see here, this r, no, here 1, r is equal to 1 in this equation. So this 1 should be less than b. B means here b is 4. So already 1 is less than 4 only, and it should be greater than 0, isn't it? Yes, 1 is greater than 0. So any one condition can be satisfied, either greater than 0 or equal to 0. Here we get the condition as greater than 0. So we also here we also get that r satisfy the condition. It should be less than b and it should be greater than 0. So we conclude that any positive integer can be written as the product of its divisor and quotient plus remainder. See here, 45 is written as the product of its divisor. What is this divisor here? Divisor is 4. So here 4 is the divisor. So 45 is written as the product of its divisor 4 and quotient. Quotient is here 11 plus remainder. Remainder is here 1. So not only 45, any positive integer can be written as the product of its divisor and quotient plus remainder. And also here the remainder should satisfy the condition. It should be always less than its divisor and greater than or equal to 0. We also satisfied in this equation, in this example. See here we get the remainder as 1. It is less than its divisor 4 and it is greater than 0. Like that way only, every time our remainder should be less than its divisor and it should be either greater than 0 or equal to 0. That is only explained in this Euclid's division lemma, in our Euclid's division lemma. That is, any positive integer a can be written as the product of its divisor b and quotient plus remainder. Also, in order that r should satisfy the condition, r should be less than its divisor b and greater than or equal to 0. Hence proved our lemma. Thank you. If you like this video, please like our channel, share our channel, and also subscribe to our channel. Thank you.